All right, everybody, welcome to the week 1 lecture for AD 340 mobile application development. This is section 5210. I am very happy to be with you all. If you don't know who I am, if this is the first time you're seeing my face, I am Nate Ebel. I will be your instructor for this quarter. And before we really get into the bulk of the new content for this week 1 lecture, I want to take a little bit of time, since this is our first kind of official lecture, and just review a little bit about kind of the week 0 stuff, our syllabus, and just kind of get us all on the same page. So if we go here, week 0 review. If you're not familiar with week 0, hopefully, if you're finding this, you've been into Canvas. Week 0 is just a little bit of housekeeping stuff, trying to get us familiar with Canvas, with the structure of the course, all of that. So in particular, for week 0 here, I want us to make sure we review the syllabus. The syllabus you can find by going into Canvas and clicking the home section here on the left, or explicitly going to the syllabus section. They'll both take you to the same place. So please take some time, review the syllabus, specifically kind of the summary, required materials, which we'll really be getting into today. That's kind of the purpose of week 1. Also the class structure, topics, grading, all that good stuff is in the syllabus. So please review that if you haven't already. And again, I want to explore the week 0 module as part of this as well. So come over to the module section, and week 0, you see this start here, hopefully a nice indicator of where we should all start. But take a look at this, watch the welcome video if you haven't, check out the week 0 lecture video as well. It gets more in detail into kind of the syllabus and some of that stuff. In particular, the class communication section is really important, and again, required tools we'll kind of talk about now. And then also just want to draw your attention one more time to our first homework assignment, which is really just this welcome discussion, introduce yourselves, and just share what one of your first mobile or favorite mobile apps is. This is really just meant to be a simple discussion to get us all chatting and familiar with the tooling and everything. All right, so now a couple announcements for week 1. I know we're just really starting, but there are a couple things I wanted to call out already. So first off is that all official announcements, they'll all be made within Canvas. So you will see announcement posts related to these items as well. And that will be the place to go. All official communication will happen there. That said, I do want to call these out. So first off, office hours are going to be moved to Monday evening, I think. It sounds like there were some scheduling conflicts with people on the Thursday time that I had initially called out in the syllabus. So that will all be updated, and hopefully Monday evening works better for people. And then I also want to clarify a point that was in the syllabus as well. There was an optional item in there about a $25 Google developer account fee. And I just want to point out that that is completely optional. It will not have any kind of impact on your grade or assignments or anything like that. Basically, just at the end of this course, we're going to have kind of a bonus lecture about how to actually take the apps we've built and upload those to the Google Play Store. And to do that, if you want to do that with your app, you will need that $25 account. But that will be optional, like I said. And if for some reason you do want to do that, and that $25 is, just a bit of a challenge right now, especially with everything going on. I know a lot of people are, out of work right now, things like that. Money's tight. Let me know and we'll work something out. Okay. Week 1 here. Let's just jump into this. So week 1 assignments. We just want to call this out up front so you kind of know what to have in mind as we're going through this. Both of these assignments for week 1 will be in Canvas. There will be go to this here. There we go. So there will be a discussion assignment again for week 1, and then there will be an app assignment. The discussion assignment here Again, just another simple discussion, but basically want to get you thinking about what makes a great mobile app. Does it solve a particular problem for you? Does it entertain you? Is it fast? Does it require an internet connection? We'll talk about some of these types of things later on in the lecture, but these are just some of the things to keep in mind for that assignment. And then the app assignment this week, which will likely make more sense once we get into the lecture. But essentially, we're going to build our first simple Android app and then basically change just a single text item in that app, customize it a little bit, and then be able to run that app. So again, we're going to walk through all of that in the demo later. But this is essentially what the homework assignment will be. So take a look at both of these. These will be due Wednesday, the 22nd. And yeah, we'll just take a look at those. Now that we're on the same page, we can move on with the rest of the lecture. Okay, so as I mentioned here, we have our discussion assignment, what makes a great mobile app, features, price, all that kind of stuff. Our app assignment, creating our first Android app. Yep, all of that's good. All right, here we go. We can finally start off now. Introducing mobile app development. So why should we learn app development in the first place? Why pick app development as opposed to desktop development or backend development or machine learning, anything like that? Well, there's a few things that kind of stick out about app development that I find particularly interesting, and also I just think kind of place it uniquely within some of these other disciplines. So first off, there are an estimated 3.5 billion smartphones in the world. So that's obviously a huge number of devices. That's something like one smartphone for every 2 people in the world. But then if you add in tablets, smartwatches, IoT devices, that number becomes much larger. Finally, also, mobile devices, they tend to just be less expensive and more portable than, let's say, a laptop or a desktop computer. So this makes them easier to carry around, easier to sort of buy and sell. This also means that smart devices have become ubiquitous. It's very common, particularly in the United States, much of Europe. It's very common for basically just everybody you meet to have a cell phone. Even in sort of emerging markets, places, South America, Africa, very much it's a mobile first sort of mindset where people will pretty much all have a mobile device, but maybe not have a laptop or something. So app development is something that we can build that pretty much everybody can take advantage of. And then, like I said here, we saw those numbers in the last slide. You know, the majority of people in the world have at least one smart device. I don't know about you. I personally have several smart devices, particularly as an app developer myself. I've got testing devices, personal devices. So yeah, there's just a lot of smart devices out there. With this huge number of devices out there, this presents a really large market opportunity for businesses and for software developers like myself and like you all. If you pull up a LinkedIn and just do a quick search for mobile developer, there's over 30,000 jobs that pop up there. Those numbers change and grow and shrink depending on what type of mobile developer. So maybe it's native, Android, iOS, all those. But basically it points out that there are a lot of jobs available right now for mobile developers. It's a big need for businesses. And there's many more opportunities for indie developers or freelancers. If you want to build your own app, you want to build your own game, or if you want to contract out to people, there's many more opportunities for all of that. So mobile's a great place to be if you're looking to kind of make money or build a career as an app developer. Now, there are some really unique challenges with app development as well. There are unique interactions that really didn't even exist before the move to mobile apps. So we have to account for things like touch, rotation, gestures. There's many different form factors, you know, phones, tablets, smartwatches, they all look different sizes, shapes, all that. And we have to account for that. There's varying performance of these devices. They might have limited network connectivity or memory. So all of these are things that we have to keep in mind. So if we look specifically at user interactions, like we already mentioned, mobile apps require touch input. But that can mean a variety of different things. So if I pull out my phone here, I might do a one finger swipe. I might use two fingers. I might swipe left or right. If I'm on a larger tablet, I might even do bigger gestures with multiple fingers. All of that is pretty complex. And then there's just like the shape and direction of the gestures. We have to be able to recognize those consistently and respond to them. We have different touch input. So, my finger, when I touch the screen, might be a different size than your finger. That might be a different size than a stylus. And we have to be able to, again, recognize all of those different things because they might mean different things depending on how we code for that. Another interesting thing is when we look at a mobile app, we don't generally have a lot of tooltips. And we don't have a mouse to kind of scroll around and highlight things to give us hints as to what a button might do. So we have to build really intuitive UIs that kind of help guide the user into common interactions and functionality. Like I mentioned before, mobile devices have a ton of different form factors. We have small phones, really large phones, tablets, phablets, weird sort of hybrids. We have folding devices now. There's a lot out there that we have to account for. And our apps have to be able to grow and shrink and resize accordingly to take advantage of those sizes. Similarly, there's not even a standard orientation. Some apps might be run really well in portrait, but not in landscape. Folding devices bring a whole new element to this because you can have portrait and landscape sort of intermixed very quickly with each other. Something like a Chromebook that's running an Android device might have resizable windows, and that orientation might change really quickly depending on how you scale it. So again, another challenge there. And there's no standard really hardware in these devices. You don't have a standard resolution, processor speed, amount of memory, amount of storage space. All of these things have to be accounted for to provide the best user experience possible for app users. So as I mentioned, limited resources, mobile apps go anywhere. That's really probably their biggest strength, that we can take our mobile devices with us anywhere. And most people do take them with us anywhere. Even if we're going out camping, going on vacation, we have our phone, even if we maybe don't have a laptop or a desktop computer with us. This makes it challenging. We might not have internet, or we might have internet and it might be really slow. So how will our app respond to that? We might be on a data plan where internet is really expensive. This is particularly important in emerging markets like Africa or South America. You might have to actually walk several miles to an internet cafe just to sit down and pay for some internet to, check your apps. So you have to be really mindful of that and try and design and build applications that are memory efficient and data efficient. And all of that said is really the devices themselves. We haven't even talked about the people yet. And honestly, the people are oftentimes the biggest challenge in app development. A few things here. People are impatient. We might pull out our phone and check 6 different apps within a minute. So our apps have to be really quick. They have to be snappy. They have to be performant. We get distracted. We have lots of notifications coming in. We have all different kinds of content. We might jump to music, to YouTube, to Instagram, to Twitter, to our email. All of those things, again, are keeping us distracted, keeping us jumping around. So we have to provide quick, functional experiences for our users if our apps are going to have a chance of making it. And even then, even if we provide a good experience, there's tons of competition from other developers out there, from other companies that are all trying to do the same thing. So we have to, again, provide a great experience if we want to kind of rise to the top of that competition. And then finally, building software is challenging. Regardless of whether it's mobile or machine learning or backend development, software is challenging in of itself. And we can't minimize just the complexities involved with building a working piece of software. So yeah, we talked a bit about this, some of the different types of things that kind of distract people, checking a calendar, playing music, ordering food, skimming social media. All of these things can distract us, and they also mean that we expect really quick, useful functionality. Reasons why we want to have quick, useful functionality. Well, people will uninstall your app if it's slow or unresponsive. People will abandon your app if they don't think it's immediately useful. Okay, so that's a bit about mobile app development. Now I want to talk just a little bit about the different types of mobile app development we have out there. And when I say different types of mobile app development, I'm really referring to sort of the technologies used to build them. In a perfect world, any of these technologies would build an app and a user experience that was really transparent to the users. Ideally, your users shouldn't be able to use your app and tell what technology you used to build it. However, that's often not the case. So we'll talk a little bit about these. So first off, we have native app development. So this is iOS development or Android development. We have this is iOS development or Android development using the native tooling coming straight from Apple and Android, and we'll talk a bit about that in a second. We have cross-platform development. These are frameworks that you might have heard of, such as React Native, Flutter, Xamarin, things like that. And then we have the mobile web. So let's talk a bit about each of these. Native app development. So when we say native app development, people typically mean kind of the standard tooling and processes coming straight from Apple for iOS or from Google for Android. Native experiences, native apps give you the most control over the user experience. When you pull out an Android device, for example, from Google, it looks a certain way. And many apps actually follow very similar visual guidelines, and there's common interactions. Those are all things that you expect from a native experience. Native applications also tend to give you the best access to hardware, to sensors, to APIs. They bring you the closest you can down to really the hardware level, so you have full control over what the device can do. So these are all good things. There are some challenges, though, with native development. Because iOS and Android require different tooling, different languages, different operating systems, all of that, it means that to build native mobile applications for both platforms, this typically requires multiple code bases and usually multiple teams as well. So if you're a single person wanting to build apps, or if you're even a company wanting to build apps, you have to take that into account. And then additionally, because these are different platforms, skill sets, all of that, it means it requires specialized skill sets. So you have to learn different sets of skills and tools to build an iOS app natively versus an Android app natively. Now, next up is cross-platform development. Cross-platform development aims to write a single code base, really a single app that can be used on both iOS and Android. And this is a great way to leverage skills of web developers in particular for something like React Native, or just other developers on your team, because they can learn kind of a single language and set of tools and build apps for both platforms. This has the potential to be a lot faster for certain types of projects. Now, there's a lot of debate in the community about what's better, cross-platform or native. I don't really want to get into that too much. But my personal preference is it just sort of depends on your needs for the project. But definitely for small one-off projects, cross-platform can be a really great option. One of the drawbacks to cross-platform applications is that you have less direct access to the hardwares and sensors. Usually cross-platform sits on the native code. So you might have like the hardware right here at the bottom, followed by the native operating system, so maybe Android, and then you might have something like Flutter that sits on top of that. So it kind of adds another layer, and each layer you add sort of abstracts things and makes it more difficult to get to that low-level performance and sensors and all of that. And then one of the biggest challenges with cross-platform development is building user experiences that look and feel native. You know, when I pull out an Android app, I expect it to behave a certain way. If I pull out an iOS app, I expect it to behave a certain way. And cross-platform makes that challenging since you're kind of building a single code base and experience for both. So that's one of the big things to keep in mind when building for cross-platform. And now the third option we'll talk about here is mobile web. So mobile web is essentially regular web development that's optimized to work well on mobile devices. And that can even, to some extent, give you access to certain sensors and stuff on the device. So this is a great way to leverage your existing web developers and even a lot of your existing web code, because a lot of it will just run natively. So there's less unique code to have to write. It's also extremely fast to ship and distribute web code because you can just deploy it directly to your website or your APIs, anything like that, which means users immediately have access to it. This is in direct contrast with native or cross-platform apps that have to be distributed through the app stores and can sometimes take quite a bit longer. Challenges with mobile web include, the least amount of access to low-level hardware and sensors. So that can be a big challenge if you're building an app that uses a lot of that stuff. And then just widely varying user experiences. There really aren't a lot of standards for mobile web experiences. It's really just like the web. It's kind of the Wild West. You can sort of do whatever you want. So this can present unique challenges if those mobile web experiences aren't taking into account the mobile experience as well, not taking account the sizes and the resolutions and the orientations and all that stuff. So it can be tricky. So as we've talked through those, I just want to kind of call this out. Picking a mobile technology is a complex decision. People get paid lots of money to make these types of decisions. It takes a lot of experience, maybe some instincts. It takes a lot of domain knowledge. You have to understand your project's capabilities, your company's needs. There's a lot that goes into that, and we're only going to have a limited time this quarter, so we're not really going to get into any of this outside of native Android development. So why then are we going to choose native Android development? Well, Android devices account for over 70% of all mobile devices in the world. I think it's something like 72% of all mobile devices are using the Android operating system. As of 2019, Google announced at their big Google I/O conference that there were over 2.5 billion Android devices out there in the world. We're another year removed from that, essentially, so I'm sure that number has gone up quite a bit. So obviously Android out here is just a huge market share and so many devices. Android is also much more approachable. The devices tend to be less expensive. Certainly they have high-end expensive devices, but they also have many, many low-end, cheap, affordable devices. And these devices really make Android, again, ubiquitous in all parts of the world. You know, if you go to somewhere like China, Brazil, Nigeria, those places are all Android first. And they're using these lower end devices typically just because they're more affordable. They're easier for them to get their hands on. Additionally, not just the devices are cheaper, but it's actually cheaper to even just be an Android developer. To be an iOS developer, you have to pay, I think, roughly $100 a year to keep your account active. For Android developers, you pay $25 once, and that's just to be able to upload it to the Play Store. You can actually build the apps and deploy them and distribute them on your own without paying any fee. And you only pay the fee once. So that part's much easier as well. Also, Android apps can be developed on pretty much any operating system. So whether your machine is a Windows machine, Mac, Linux, or even Chrome OS to some extent, you can download and install the Android SDK and build tooling and start building Android apps. This means that the devices to build them, the laptops, the desktop computers, they're much cheaper compared to building for iOS, which requires a Mac. I already mentioned the cost of the developer account, so $25 for life, much cheaper than $100 a year. And another nice thing is that Android app reviews are much quicker. Apple is notoriously frustrating to deal with when submitting application reviews. It does keep their bar really high for the quality, but also sometimes it can be really frustrating to work with them as an app developer. Android, on the other side, they don't do as much in reviews, so it makes it much faster for you to be able to ship an app out to the Play Store. So all of that said, Android it's approachable, it's cheaper, it's really easy to get up and running. The tooling and stuff is free. So that's why we're going to be exploring Android development this quarter in this course. So now let's plan our step forward, or plan our path forward a little bit. I just want to frame again where we're going and what you can expect in this course. So my goal for you all is to really go from wherever you're at now in terms of experience with app development. So that might be 0, that might be, you've dabbled a little bit, but want to go from where you are now to essentially being app developers. And my definition of an app developer is just someone that's built an app. So really after this first week, you will all be app developers based on my definition. And hopefully by the end of this quarter, we're going to have built an app similar to what is often expected for take-home job assignments during an interview process. So by the end of this quarter, hopefully you'll have the experience needed to actually work on and complete a take-home assignment for an Android job interview. So we're going to start early in this quarter, as early as really this week. We're going to create our first simple Android app. We're going to then, add functionality to it throughout the quarter. We'll learn to deploy the app, to test it, to actually play with it on our device. And then at the very end, like I mentioned before, I'll even show you kind of in a bonus lecture how to actually upload that app to the Play Store and be able to download it from Google Play, show it off to your family, your friends, all of that, or more importantly, probably show it off to people when you're interviewing for a job. So, all of that said, the first step really for us starting to become Android developers here is we need to set up our development environment. And so our development environment for this course is going to be pretty much comprised of 3 things. It's going to be Android Studio, which is going to be our IDE, Git, which we will use for version control, and GitHub, which we will be using to store our code, and also will be needed for submitting homework assignments. So now hopefully you're all somewhat familiar with Git and GitHub. If you are not, I have included resources in the module for this week on how to get set up and running with those. I have a couple tutorial videos linked to help you. And I'll also be going through some of that in the demo for this week's lecture as well, which will come a bit later in this recording. Now, to start, Android Studio is an integrated development environment for Android. If you're not familiar with integrated development environment, it basically means that it's a really fancy text editor that has a lot of built-in tooling to make building for Android easier. It's technically possible to build an Android app just using a plain text editor and the command line basically, but it would be a lot more work and hassle. So Android Studio is a way to just make that easier for us. Android Studio is built officially by Google, so that team maintains that tooling and makes sure there's really tight integration with all of the APIs and everything. And then Android Studio is actually built on top of another IDE called IntelliJ, built by JetBrains. And JetBrains is known in the industry for having really best-in-class tooling. And so that means that Android Studio gets to take advantage of all of that tooling and is really a really nice tool for us. It's made Android development much nicer since it was introduced several years ago. Oh, and before kind of moving on, the demo will walk through in great detail how to download and install and set up Android Studio. I'll be doing it on a Mac, but I also have linked to some video resources on how to do this for Windows too. And the general idea is very much the same. There'll also be some links in the module for how to walk through the setup process that comes straight from Google. So you'll have kind of several resources there to help you get this set up. So in addition to Android Studio, there's some Android Studio kind of tools that we'll need, specifically the Android SDK, which is all of the kind of the libraries, the code, the APIs, the tools, everything that'll help us actually build the app. There's the Android Emulator, which is essentially just a virtual device that lives on our development machine that lets us test our Android apps without having to use a physical device. And then there's the platform and build tools that again just kind of go into making the building of the app simpler. So all of those, again, we'll walk through how to set those up in the tutorial video or demo video a little bit later on. So before we kind of get into the demo, if you want to kind of go out and explore on your own, this is the link for installing Android Studio. Basically developer.android.com/studio/install. Pretty straightforward there. That'll show you a nice download link. You can get started there. And that pretty much takes us now to the demo. So we'll kind of cut over to that video, walk through that process. Okay, so to start, just open up Google and we'll search for install Android Studio. We'll see the first link there is the one we want. It says download Android Studio and SDK tools. We'll go ahead and click on that, and it should take us to developer.android.com/studio. This is the landing page for all things Android Studio. And what we're looking for here is the big green button that says download Android Studio. Now below that, you notice here it points out 3.6.2 for Mac. So it's saying, the current version is 3.6.2, and it's also recognized my operating system. If you click on the more download options, it'll take you to this section here that shows that we have downloads for Windows, for Mac, and for some different Linux distributions. So whatever your development machine is, Android Studio should run on it just fine. And like I mentioned before, it'll even run on Chrome OS with a little bit of finagling. So if I scroll back up to the top, we're going to go ahead and click Download Android Studio. I'm going to accept the terms and conditions. And once you've satisfied those terms and conditions, we'll click Download. And this will kick off the download process. It's a pretty big download, so it'll take some time. Here I've sped it up, and I've double-clicked on that downloaded DMG file. If you're downloading this on Windows, it'll probably be a .exe file. Once that's kind of extracted, here on Mac, it's going to ask me to drag this over to my applications folder, and then I'll double click on it. On Windows, it should have a similar sort of installer process that kicks off. Once it's done kind of extracting files, I'm going to go ahead and open it up. Now, once Android Studio is opened for the first time, it should look for any available Android SDK. And so in this case, because I don't have one, it's going to say missing SDK. So we want to install some version of the SDK now. And by default, it's going to download Android SDK for version 10, as well as some of the associated tools. And we'll go ahead and leave the SDK location as the default in this case. Once we're satisfied, we'll click Next. And so here it'll actually review what's going to be installed. So that'll include the Android emulator, the build tools, the platform APIs, the platform tools, basically everything we need to get started building our first Android app. Once we've kind of reviewed this, we can go ahead and click Finish to continue on with the install process. That'll take some time, but once it's done, you can click Finish. Here, we next want to go to the Configure section. And we want to open up the SDK Manager. Now that might be a little bit different on Windows, but what you're looking for is SDK Manager. Now here we can see that we have the Android 10 APIs installed. But you see we have a lot of other versions too. So you might want to install some of those if you were doing this professionally, but for now, just the one is fine. If we tab over to Build Tools, SDK Tools, we'll see there we have an update available for our build tools. So in this case, I'll go ahead and click that so I can get the updated build tools. We'll see that we already have the emulator installed as well as the platform tools. Now there's a couple other things we're going to want to go ahead and download as well, just to be safe. The first one, down at the bottom, we see the Intel Emulator Accelerator, the Haxum installer. If you have an Intel processor that supports it, this really speeds up your emulator. So I suggest downloading that if you can. And then we'll download the Android documentation. We'll go ahead and click Apply, then hit OK. This should bring us to a license agreement page. We'll click on each license and click Accept. Once we're done with that, we'll click Next, and that'll kick off the install here. Once again, this will go fast. I've sped it up. Eventually, you'll get to this emulator section. Here you can define your settings for your emulator. Now, by default on my machine, it recommends 4 gigs of memory. You can slide this to be whatever you want, but I recommend just clicking the Use Recommended Size option because that'll take into account your machine's specs, and go ahead and click Next. So here now it's installing the Haxum accelerator for me, so I'll authenticate it if it needs. And then at the end of this, you should be able to go ahead and click Finish a couple times. And now we should have essentially the first round of tools and SDKs all installed on our machine. Now we can go ahead and click Start a New Android Studio Project. And we're opened up into this little creation wizard. And we see we have several tabs. We're started on the phone and tablet tab, and we have templates for a variety of different sort of starter projects. But you also notice the other tabs. We have Wear OS if we wanted to build a watch application. We have TV for Android TV applications. We also have Android Auto and Android Things for IoT and automotive. All of those are great, but we're not going to use them in this course. So we'll go back to the phone and tablet section, and we're just going to click on the empty activity section for now and click Next. On this next screen, we get to name our new app. So in my case, I'm going to update the name, and instead of my application, I'm going to call this something like AD340. Feel free to name your application anything you want, but if you name it AD340, it'll be easier to follow along. Next, the package name. This is kind of like your personal identifier. So for me, by default, I use com.goobar.io since that kind of matches the domain of my website. However, you could do something else like com your name or com something, anything you want really. So in this case, I'll go back to com.goobar.io.AD340, but that package name is the unique identifier for your app. Next, I'll go ahead and update the save location of my project. I recommend you define a new folder for your course. In my case, I already have done that. I have one called AD340. Now within that directory, I'm going to create a folder called App. You can also define it just directly in the save location path. Now for language, we're going to go ahead and leave it as Kotlin since that's the default. And for minimum SDK, we could leave it at Android 5.0, but I'm going to actually update it to Marshmallow, and I recommend you do the same. This makes it a little bit easier to develop for and still accounts for about 85% of all Android devices. After that, we'll go ahead and click Finish. And you have now successfully created your first Android project. Now that might take a little bit of time to finish indexing and kind of setting things up. So you might see that little progress indicator in the bottom right. But this is really it. We now have a working Android application that we'll be able to actually install to our emulator in just a little bit. So again, notice the progress indicator in the bottom right. Now we're going to go up to our menu and we're going to click the little button that looks like a phone with an Android in front of it that says AVD Manager. Or we can go up to our menu, go to Tools, AVD Manager. AVD stands for Android Virtual Device. So this is where we'll create our first emulator so we can test our app on our computer without needing a real device. So we'll click Create Device. And now in this case, you can choose what type of device you want to emulate. So I'm going to choose a Pixel 3 XL device since it's one of the more new high-end devices. I'll then click Next. Now we have to download a system image that basically defines the version of Android and what operating system that device will be running. So you see we have a number of different image types here that are kind of customized based on what's pre-installed on them and what processor your computer has. Now, by default, I would recommend just sticking with the options on the left-hand side under the recommended section. So you see here on recommended, we have Android R, which is the pre-release version they're working on, or Android Q, which is the latest stable version. So I'm going to go ahead and click download on the Q, and this will start off the download, which again will take a while. I've sped it up. And so now, once that's done, we can click Finish. Eventually we can click Finish. There we go, click Finish. And so now we can go ahead and select Q for our new Android emulator settings, and then click Next. Here you can further configure and name it, but I'm going to leave the default and click Finish. And you'll see here, now we have a configured virtual device. So now we have our new Android app. When we look over on the left-hand side of the screen here, this is the project pane. This is where the files and the resources and the build configuration all live. Now, by default, it uses this Android drop-down section, which hides a little bit of the complexity of the build, which is actually really nice in some sense. But for now, we're going to switch over to the project pane. The project option shows you the files exactly as they look on your file system. So if you opened up the directory that this project was created in, it would look just like the project pane does right now. Under this app directory, we can navigate to source, main, Java, and we'll see here we have one file called main activity. Now we're going to get more into what this all means next week, but for now, main activity is a class that represents what we see on the screen. Now, if we go ahead and click the green arrow, we can deploy this to our newly created emulator. Now, after a few moments, that emulator should appear on your screen, and Android Studio will install that app to the emulator. So here my emulator is now opened up, and after a few moments, we see here we have a new app. You see 8340 at the top, that's my app name, and Hello World printed on the screen. Now this is basically what our homework assignment is. You're going to be tasked with customizing the text printed out to the screen. So let's quickly review kind of where that text is actually coming from. So the activity represents everything we see here on our screen. All this colored stuff, the message, that's all defined by main activity in this case, which again is just a simple Kotlin class. We'll talk more about exactly how to define a class in later lectures. But for now, we can notice the class and then this onCreate method that says when this is created, define this view that will be displayed on the screen. So notice the setContentView method call here. Now that method is referring to a layout called ActivityMain. So once we open that up, we'll see that a layout in Android is defined using XML. And again, we'll get into what this really means and is doing next week. But I just want to call your attention to this text view element down below. Specifically this line that says Android:text equals hello world. This is the line that is defining what we see on our screen. So instead of hello world, let's type hello 8340. Once I've updated that line, I can once again run the app by pressing the green arrow in the toolbar, and it should redeploy our app to our emulator with that new text included. So I've clicked the green arrow, it's reinstalling, and now we see hello 8340 printed out to our emulator. And now once again, this time I'll change it hello 8340, to something like my name is Nate. I will rerun this once again. And now again, you can see that the text has changed. So this is what you're going to have to do for the first part of your homework assignment. You'll create this project, and then you're going to modify that text to say, hello AD340. And then if you want to throw something extra in there like your name, feel free. Okay, so now we have our simple Android app ready to go. We want to walk through just how to get this into GitHub. Now there's a variety of ways you could do this. You could do this from the command line using Git. You could cd into your current project directory, initialize that directory as a Git repo, and then push that up to your GitHub remote. If none of that makes sense, if you're not familiar with that workflow, totally fine. We're going to walk through in the demo how to push the code to GitHub directly from Android Studio. Okay, so in Android Studio, we'll go to the menu and click on the VCS tab, which stands for Version Control System. And we'll scroll to the bottom. And so first we're going to click on Enable Version Control. And it's going to ask you what type we want. And we're going to enable Git, since we're going to be using Git and GitHub for this course. Once we selected Git, hit OK. So now this project has been initialized as a Git repository. If we go back to the VCS menu, now we can click Import into Version Control, and then we can click on Share Project on GitHub. Now it might ask you to authenticate at some point during this, in which case you will enter your GitHub username and password. Here, it's now asking me to fill in the details for this repository. So I have, by default, it's picked up the app name as a repository name. The remote will just default to origin, just leave that as it is. Now we can fill in a description. I really encourage you to put at least something in here. So I'm going to put a project code for AD340. And then you can go ahead and click Share, and it will create a new repository on GitHub. You notice here that it'll point out if your name is incorrect or not. In this case, it complains because I had a space. I'll change that. I'll click Share. Now it's going to ask you to create a commit if you don't have one. If you don't have one, just leave the defaults and go ahead and create that initial commit and click Commit. You should see a dialog that says Successfully Shared Project on GitHub. Once you've done that, you can open up a web browser, navigate to github.com. You'll want to sign into your GitHub account. So here my GitHub username is N8EBEL. I'll enter my password. I actually enter the wrong password there. I'll enter the correct password this time and go ahead and click Sign In. Bear with me. There we go. Now I have two-factor authentication set up for my GitHub account since I use it for work. So I'll go ahead and enter the temporary auth code here. All right, so now I'm into my GitHub profile, and under my repository section, I now see an AD340 repository, which was just created from Android Studio. And so I can see all of my app code was just pushed 1 minute ago, it says. So that's it. So now we have our code in GitHub. So now the next thing we want to do for our homework is create a README. READMEs are really important because they help sort of other people know what to expect in this. So by default, I want to have you create some type of README that just says this is for AD340 and include your name for now. And then as we go through the course, we will update this README as we go. Once you've added that text within the GitHub editor, go ahead and add a commit message that says something like add project README. And then we'll go ahead and click on commit new file, and we'll leave it as committing directly to master. So now we have successfully added that file, and we see that GitHub is rendering our README. Now, if we go back to Android Studio, we don't have the README present yet because our Git history has not synced up with our remote on GitHub. So we can go up to our version control options in the menu, and we can click Update Project. This is going to do a pull command from Git, and then merge those changes in if needed. So now it says one file updated, one commit. And we'll see now that we have our README present on our local version of the repository. So that is kind of a basic flow there for updating your README in GitHub and pulling those changes down. Now, any way you want to do that is fine. If you want to work with Git and GitHub from the command line, that's great. And we'll kind of review that in a later lecture. But for now, working from Android Studio is quite likely the easiest way to get going. Okay, now for our homework assignments, I'm going to require that you submit an APK. An APK is essentially the application package file. Essentially, it's a zip file of everything that goes into making the app run on a device. So now we're going to walk through what that process looks like within Android Studio and where that file actually is located so that you'll know where to look for it when it's time to submit your first homework assignment. Okay, so now we're back in Android Studio. Go up to the Build tab and click on Build Bundles/APKs. Now, after a few moments, you should see a notification in Android Studio that says Build APKs, basically saying like the APKs were successfully completed. Now we'll navigate to our app directory, go app, build, we'll go app, build, outputs, APK, debug, and then you'll see the debug APK there called app-debug APK. So now one more time, let's just kind of walk through where that lives. So I'm going to go back to the root level project directory. So for me, this is called app. So I'll open up the project directory. Then I'll navigate inside of that into the app directory once again. Then I'll open the build directory, click on outputs, APK, debug, app-debug.apk. Now we'll kind of talk more about what that structure means later, but for now, this is where you can find that debug APK to submit for your first app assignment. Okay. That is it for the week 1 lecture materials here. If you have questions, please email me. I'll have office hours next Monday, and also have time during our live class session on Wednesday to ask questions. So if you watch this ahead of time, have questions, you can ask me, and I can cover those Wednesday as well. And with that, we'll go ahead and end this video, and I will see you all on Canvas or in our live Zoom session.